G'day, this is Brett Johnson, Total Earth Solutions. Today I just want to show you what we did with a little topographic mapping project about a year ago. Platform I'm in is 4DMAPPER, web mapping platform. I love it because it's built for numbnuts like me that have a very, very broad geophysical, geospatial, flight ops, airborne survey, ground survey knowledge, but not a great deal of depth, and I don't really want to be tied up in ArcGIS or high-end GIS all day. I just want to look at stuff, and that probably explains a lot of our clients too. They like us to go and do the sorted out work, and they want to go and look at their stuff in a simple platform like 4DMAPPER. So into Project Manager, this is code word for the name of the project, and there's the project. It's in Western Australia, north and east of Laverton, between Laverton and Warburton, you could say. Client needed a very, very high resolution topography and some coincident imagery. Important thing is what we added to it was the underlying open file geological and geophysical data, which as you will see ends up being quite compelling. So, you know, some of the layers that we've added here, just like you do in a normal GIS, has got the imagery layers. So this is 20 centimetre imagery that was collected concurrently with the LiDAR, mid-format camera. You know, they could have had 5 centimetre imagery if they wanted it. Would have cost a lot more, and don't know why they would need it. Good resolution as we zoom in. It's a bit slow, even though I'm on the NBM, the National Broadband Network. It's Friday afternoon, so there's lots of teenagers downloading God knows what. You can guess. So the imagery's nice, better than the Mapbox stuff that's in the background or Google Earth. Yeah, you can start to do a little bit of photo interp. You can see tracks, you can see creeks, you can see drainages, you can see costains and land disturbances. I think that's about our zoom level in total, so let's leave that as the background layer. So this is really easy to go and put any GIS, you know, spatially located file into, of any kind, be it an image or a contour or whatever. So that's the survey area, and that's the underlying imagery. The reason why we did the survey though was it's relatively flat out in this country, and sheet flows and drainage becomes quite an issue in high rainfall times, which is rare. You know, you're in the beginning of the central desert, so it does happen, but it's very rare. Pardon me. So mine layout. We got the DXF for the mine layout and added that as a polygon. You can see I'm playing with a slider. So that's the total mine layout up until the area of interest. This could be with or without annotations. As you may notice down the left hand side, there's annotation, mapping and measuring tools. Up the top you can see we can export things too, so it's quite cool. It's sort of like a potted GIS. Then we've got another mine layout, DXF with colours. So you can see the road structure in there, mine grid, plant area, etc, etc. But here's where I love it. We started adding things like the local geological structure. So if you zoom in, you can start to see some of the geological mapping. Where applicable, you can click on a line or a feature, a strike or a dip or a fault or something. Here we go. And hopefully it'll give you some of the attributes of that. Didn't work there. That's alright. It's not alright. We'll leave that. We'll bring its opacity down. Here's the 2 metre contour layer. And you can see that's pretty confusing, but if you move into this area, contour lines will get thinner. So this is derived from the LiDAR topography. It is not the problem of the program, it's the problem of the NBN. Comes up to be nice thin lines, and it's interesting how you can start to interpret features that are both in the local geological structure and in the topo, and you see in the images. We'll turn the contours off for a moment. We'll keep that there. I like that. I think that's a really nice thing to have over the image. You can actually see the strike of the direction of the geology from northwest to southeast, and you can actually see that in the imagery. What else do we have? We had the Cenozoic local geology. I need to do something with that, but you're starting to see the power of this stuff. So let's leave that slightly shaded. Oh, the bedrock geology. Now, look at that. Look at that, and the correlation with the visible features. And I'm not a geologist. I mean, Warwick, one of my partners, who's got about 13 PhDs, would growl at me for everything I've said, but at least I'm starting to understand it. And the more brains that look at a data set, the better the data set is used. And that's good for everyone. So that's the bedrock geology. Now here we come with the Clearshed DTM, and some beautiful correlation with the geology and with the topography, of course, because it's the DTM, sorry. Duh. Now we'll put the RTP magnetics underneath, reduced to pole. You can slide that up and down. You'd almost go and do a geological interp on this screen. First vertical derivative LOGC. Nice. What else? The first vertical derivative of the mag. Turn it right up. Turn the LOGC down. And we'll turn the RTP down. Yeah, look at that. Look at the correlation with the bedrock geology. So we'll turn the bedrock geology down and the local bedrock geology down, and even the Clearshed down. But you're starting to see subsurficial geology and the surface there. I think that's actually a really nice map in my innocent non-geological view. One of the ones that I found quite amazing was the residual gravity, and it runs basically as the geology does. Look at that. And then here's the radiometrics from government 400 metres. That's a ternary image, and let's go and see if that's got any correlation with the take the structures out now, with the what am I thinking? There won't be a great correlation with the mag, but let's have a look at that. The first vertical derivative of the mag. Oh yeah, there's a little bit. You can see where stuff's moving around. This is predominantly superficial. It's not all about just correlating things. I'll turn that down. But you can certainly see that there is a correlation in the surface soil radiometric response, potassium, uranium, thorium, and the drainage systems. Now imagine this, and adding some electromagnetic layers and then other geology and geophysics. Suddenly the interpretability all changes. You know, that feature there that you see optically, you also see radiometrically. and you'll probably see in the gravity, although the gravity's coarse, there it is, yeah, badunk. Although that is very coarse gravity. So the point is, 4DMAPPER does some wonderful things, almost free, quite cheaply. Putting all of these data sets together becomes extremely potent. Value adds can be, depth to basement, depth of soil cover, can apply to geotechnical information, or geotechnical information can be applied back to geological knowledge. Geomorphology can be applied back to your geological interpretation. I suppose that ultimately is what TES is all about, is the mixture of geophysical and geospatial data and turning those data into interpreted geology or drill targets or hydrogeology or geotechnical information. And I just find that for our clients and for numbnuts like me, this is a great little platform. So have a look at 4DMAPPER sometime, www.4dmapper.com, and have a look at our website at some time, www.totalearthsolutions.com, and if you need some geoscientific data services, give us a call. Cheers. And that will end that video about now.